Let's talk about the first two graphs for sine and cosine. We'll start with our unit circle. Remember, we know a handful of points along our unit circle, specifically x-coordinate of 1, y-coordinate 0, x-coordinate 0, y-coordinate 1, negative 1, 0, and 0, negative 1. If we wanted to graph sine, we know that sine is just the y-coordinate of this angle as we work our way around a unit circle. So if we start with an angle of 0 radians, the y-coordinate is 0, and therefore our function starts at 0. As we increase to pi over 2, that is a 90-degree angle. Pi over 2 radians is way up here, with a y-coordinate of 1. As we keep rotating around the circle, producing a pi radian angle, we can see once again the y-coordinate is back at 0. If we keep rotating around to 3 pi over 2 radians, we notice our y-coordinate is now negative, down here at negative 1. And as we complete our loop, we have a full rotation of our circle back to our initial angle. 2 pi radians has a y-coordinate of 0. You can double check this on your own, but if we go the other way, the negative angles will be a mirror image of this. If we put a smooth curve through all of these points, we get our graph of sine, which looks kind of like this. We'll show this on Desmos during class. Similarly, for cosine, we have all the same points around a circle, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. But this time we'll be looking at the x-coordinates as we increase our angles around a circle. If we start with a 0 radian angle, cosine starts with an x-coordinate of positive 1. As we rotate around the circle pi over 2 radians, that's our 90-degree angle, our x-coordinate decreases to 0. As we keep rotating around the circle, pi radians, or 180 degrees, we can say our x-coordinate is now way down here at negative 1, before recovering and going back to 0 at 3 pi over 2 radians. Finally, as we complete our circle, we rotate a full 2 pi radians around, we're back at an x-coordinate of 1. Once again, you can see what happens on your own when we rotate the other way. And if we put a smooth curve through this function, we get something that looks like this. As we'll see in class, these two are actually very similar to another, and we'll talk about how they're related. In class, we're going to practice finding values using all 6 trigonometric functions. We're going to look at the graphs of the new trigonometric functions that we introduced today, and we'll talk about how to simplify expressions that contain more than one trig function.